We now move ahead to another type of surds, which is called conjugate pair of surds. The sum of two numbers, one of which is a quadratic surd and the other either a non-zero rational number or a quadratic surd, is called binomial expression of a quadratic surd. A binomial surd is expressed as a plus y root b, where a is rational number not equal to 0 or it is a quadratic surd, y is non-minus 0 rational number and root b is quadratic surd. Hence, root 2 plus root 3 or 7 plus root 3 and a minus root b are binomial expression of quadratic surd. Now, what are conjugate surds? When we have a binomial expression of a quadratic surd like root 2 plus root 3, we can have another binomial expression of a quadratic surd which is root 2 minus root 3. Such expressions like root 2 plus root 3 and root 2 minus root 3 are called pairs of conjugate surds. On multiplying both these expressions, we get a rational number. Let us multiply both these expressions. Root 2 plus root 3 multiplied by root 2 minus root 3. To multiply, we use the identity which is a plus b into a minus b is equal to a square minus b square is equal to root 2 the whole square minus root 3 the whole square is equal to 2 minus 3 is equal to minus 1. Minus 1 is rational number, so root 2 plus root 3 and root 2 minus root 3 are conjugate surds. Now let us use this concept to rationalize the following binomial quadratic surds. Problem set 2b. Question 7. 1. Square root of 3 minus square root of 2. Solution. The conjugate pair of this expression is square root 3 plus root of 2. Let us multiply both the expressions. Square root of 3 minus square root of 2 into square root 3 plus square root of 2 is equal to root 3 the whole square minus root 2 the whole square is equal to 3 minus 2 is equal to 1. Therefore, 1 is rational number. Question 7. 2. 4 multiplied by root 3 plus root of 27. Solution. Now its conjugate pair is 4 into root 3 minus root of 27. Let us multiply both and see the result. 4 multiplied by root 3 plus square root of 27 into 4 into root 3 minus root of 27 is equal to 4 into root 3 the whole square minus root of 27 the whole square is equal to 16 multiplied by 3 minus 27 is equal to 48 minus 27 is equal to 21. We get the result as 21. Problem set 2b. Question 8. We now learn to write the simplest rationalization factor of the following surds. 1. Square root of 32. Solution. Convert the surd to its simplest form. Students, if we recall, we will first factorize 32 into 16 and 2. Now, root 32 is equal to square root of 16 into square root of 2. Square root of 16 is 4, which is rational number. Hence, square root of 32 can be expressed as 4 multiplied by square root of 2. 4 root 2 is the simplest surd, which is equal to square root of 32. Now students, to rationalize 4 root 2, we have to consider only root 2. To convert square root of 2 into a rational number, we have to multiply it by square root of 2. Hence, the simple rationalization factor is root 2. Problem set 2b. Question 8. 1. Square root of x raised to 3 into y raised to 5. Solution. X raised to 3 into y raised to 5 is equal to x square multiplied by x multiplied by y raised to 4 multiplied by y. Taking square root from both the sides, we get square root of x raised to 3 into y raised to 5 is equal to root x square multiplied by x multiplied by y raised to 4 multiplied by y. Thus, square root of x raised to 3 into y raised to 5 is equal to x into y square multiplied by square root of x multiplied by y. We now consider the irrational part, that is, square root of x into y for rationalization. So the factor is square root of xy, since square root of xy into root xy is equal to xy. Hence, the rationalization factor of square root of x raised to 3 into y raised to 5 is square root of xy. Problem set 2b, question 8, 3. 4 into cube root of 3. Solution. We use the following method for a surd where n is greater than 2. Convert nth root into a fractional index. Hence, 4 into cube root of 3 is equal to 4 into 3 raised to power of 1 upon 3 is equal to 1 upon 3 plus 2 upon 3 is equal to 3 upon 3 is equal to 1. So we have to multiply the number, that is 4 into 3 raised to the power of 1 upon 3 by 3 raised to the power of 2 upon 3 to get a rational number. So we get is equal to 4 multiplied by 3. Laws of indices, where a raised to m into a raised to n is equal to a raised to m plus n. Here, a is 3, m is equal to 1 upon 3, n is equal to 2 upon 3. So the rationalization factor is 3 raised to power of 2 upon 3. Let us convert 3 raised to 2 upon 3 into the surd form as cube root of 3 square, which is cube root of 9. 4. Let us find the rationalization factor of fifth root of a square multiplied by b cube multiplied by c raised to power of 4. Solution. In this case, we write the surd into index form as a raised to 2 upon 5 multiplied by b raised to 3 upon 5 multiplied by c raised to 4 upon 5. Since 2 upon 5 plus 3 upon 5 is equal to 1 for a. 3 upon 5 plus 2 upon 5 is equal to 1 for b. 4 upon 5 plus 1 upon 5 is equal to 1 for c. We multiply a raised to 3 upon 5 into b raised to 2 upon 5 into c raised to 1 upon 5. Hence, a raised to 2 upon 5, b raised to 3 upon 5, c raised to 4 upon 5 multiplied by a raised to 3 upon 5, b raised to 2 upon 5, c raised to 1 upon 5. We get a into b into c, so we have used the law of indices. A raised to 2 upon 5 plus 3 upon 5 multiplied by b raised to 3 upon 5 plus 2 upon 5 multiplied by c raised to 4 upon 5 plus 1 upon 5 is equal to a raised to 5 upon 5 multiplied by b raised to 5 upon 5 multiplied by c raised to 5 upon 5 is equal to a multiplied by b multiplied by c. So the rationalization factor is a raised to 3 upon 5 into b raised to 2 upon 5 into c raised to 1 upon 5, which in surd form is fifth root of a raised to 3 into b raised to 2 into c. We move ahead with simplification of expressions involving surds. Here students, remember that we have to use all the laws of surds, laws of indices, converting surds to same order. What to use will depend on individual example. Let us understand by solving few examples.